This course will describe the different ways to measure AC voltage and current and how each of these measurements is related. In addition, the course will explain the relationship between DC current and the effective value of AC current. These are the objectives for this course. Analysis of the AC power generation process and the alternating current we use in almost every aspect of our lives is necessary to better understand how AC power is used in today's technology. As we have discussed previously, the output voltage of an AC generator can be expressed graphically by use of a sine wave. When a voltage is produced by an AC generator, the resulting current varies in step with the voltage. As the generator coil rotates 360 degrees, the output voltage goes through one complete cycle. In one cycle, the voltage increases from 0 to Emax in one direction, decreases to 0, increases to Emax in the opposite direction, that is, negative Emax, and then increases to 0 again. Before we continue, there are a couple of terms you need to be familiar with. The first term is period. When referring to an AC generator, the period is the time it takes for the generator to complete one cycle. The second term is frequency, which is the number of cycles per second being produced in the generator. Frequency is measured in Hertz, which is abbreviated Hz. In the example shown on this slide, assume the time elapsed is 1 second. Therefore, the frequency will be 6 cycles per second, or 6 Hertz. One way to refer to AC voltage or current is by peak voltage, abbreviated E sub P, or peak current, abbreviated I sub P. This is the maximum voltage or current for an AC sine wave or the peak value for voltage or current. The value most commonly used for AC is effective value. The effective value is the amount of alternating current that produces the same heating effect as an equal amount of direct current. In simpler terms, 1 ampere effective value of AC will produce the same amount of heat in a conductor in a given time as 1 ampere of DC. The heating effect of a given AC current is proportional to the square of the current. The effective value, being the root of the mean or average square of the currents, is known as the root mean square or RMS value and can be calculated by squaring all of the amplitudes of the sine wave over one period, taking the average of these values, and then taking the square root. Remember, the effective value of AC voltage and current will always be less than the peak value. Another way of stating the AC voltage or current value is to state it as an instantaneous value. The instantaneous value is simply the value of the current or voltage at any particular instance in time as shown on the diagram. This value can be anywhere from 0 to the peak values, depending upon the time chosen to determine the value. When needing to determine the effective or peak value of AC voltage or current, there are two equations which will allow you to perform the conversion. To find the effective voltage or current value, multiply the peak or maximum voltage or current value times 0.707 as shown on the slide. If, on the other hand, you want to determine the peak value of voltage or current, multiply the effective voltage or current value by 1.414 as shown. Normally, when you encounter an AC voltage or current value, it will be stated as the effective or RMS value. Therefore, you may assume when no subscript is displayed for an AC voltage or current value that it is the RMS value.